Hello student, hi, good evening. So today we are going to see the question of ISRO. Okay, we are going to solve this. So this is the test. This is the series of 2018 ISRO. So now we have reached up to question number 18. Okay, today we are going to solve this question. This question is about the clock frequency and system frequency. He Here the question it is given that there is three D latch. Okay, so D latch circuit. So because this clock here is no edge is shown here, this means what? It is just a D latch circuit. Okay, so D latch circuit here, clock external frequencies is applied and system clock frequency is applied to this circuit. Okay, so now this circuit is what? This is a D latch, not a D flip flop, because no edge is there. So this means it is a D latch D latch circuit. Okay, so now these are three D latch circuit and its output is given as this. Okay, so these Q3 output and Q2 output is applied to what? This is applied to NAND gate. Okay, so NAND gate. Then asking what is the functionality of this? What is the functionality of this circuit? Okay, and given that condition is given that here system clock frequency is greater than 4 time of this external clock frequency. Okay, external clock frequency. So it is given. Now if it is like this, then we can say that 1 by ts is greater than 4 time of 1 by t external. Okay, so now from here we can say that this t external is greater than 4 time. Okay, 4 time of this system time. Okay, system time cycle. Okay, so frequency is system clock frequency is 4 time of external clock frequency. So then here time period of this system clock is 1 by 4 time of this external clock frequency. Yes, so now from here we will see what we are going to see, what functionality, and it is here it is this is simultaneously it is applied to all the D-latch circuit. Okay, so it's simultaneously it is applied. So now now we will see here. Okay, so now let us see here. First of all, we will see it through timing diagram. Okay, so let us draw the timing diagram. First of all, this system clock frequency is 4 times of that external clock frequency. First we will draw this timing diagram for this clock frequency. So let us see this in this side. Okay, so this is my system clock frequency: 1 2 3 4 5 6 7 8 9 10, like this. Okay, so now here this is for what? System. Okay, system, this is my system clock. Okay, so now then here if you see, now for external clock frequency, this is external clock frequency. If you see, this is what? This is 4 time. Then time duration, if you see, for clock external clock is what? This is my first cycle. Okay, so this is my first cycle, second cycle, third, fourth. Okay, fourth. Now see, 1 cycle, 2 cycle, 3 cycle, 4 cycle. Okay, 4 cycle. So it will start from here, this up to 4. Okay, so now it is 4 time of this system clock. Yes, this is my ts, like this is my ts, this is my 2 ts. Okay, 3 ts, 3 ts, 4 ts, 4 ts. Okay, so this is 4 time of this. So now next, up to next. Okay, so this is first, second, third, fourth, like this only. Here first, second, third, fourth, up to next it is low, and at fourth it is high. Okay, so like this is my first clock. Here this is my t and t by 2 half. Okay, and this is my t. T, and this T external, T external. Okay, it is 4 time of this. So now this is half cycle for this, what, for external clock. Okay, now let us see, this is what, 1 TS, 2 TS, 3 TS, 4 TS. Okay, so this is my TS, 2 TS, 3 TS, 4 TS. Okay, now we will see here, for what, for Q1, output. Initially, if you see output, this, for this is my cycle, time duration of cycle for system clock. Okay, so system clock, and this. Now see here for Q1, this is not, let us see this, for Q1. If you see for Q1 it is initially it is same. Okay, so if you see for D latch, okay, it will get delayed at the output of, at the output it will get delayed by what, it will get delayed by 1 cycle. Okay, at the output, if you will see this Q1, this Q1 at the output, it will get delayed by 1 cycle. Okay, it will get delayed by 1 cycle up to this. Then next it will get delayed by up to 1 cycle. Okay, so now like this. So this is for Q1. For Q2, again it will get delayed, because D latch means it is delayed. Okay, delayed latch. Okay, it will get delayed by 1 cycle. Further Q2, it will get delayed by 2 cycle up to this, So this is my second. Okay, it will get delayed by 2 cycle. Further, here it is. The next is this. It will get like this. Okay, so now for Q3, it will get again delayed by further 1 cycle. So total is 3 cycle. So here it is. So it will get delayed like this. Now I think it is not visible this side. Okay, I will draw this Q3 directly here and Q3 and Q2, because output input to the NAND gate is Q2 and Q3. Q2 is this. Okay, so let us draw this Q2 here. Q2. This is my Q2. Okay, so this is my Q2. Under this 1 cycle, how many clock cycle is there of system clock? 1, 2, 3, 4. Means 1, 2, 3, 4. So 1, 2, 3, 4. Okay. Similarly, next 1, 2, 3, like this 4. Similarly, 1, 2, 3, 4. Okay. So this is for Q2. Q3 is get delayed by 1 cycle. Okay. So 1 cycle of what? System clock. 1 cycle of this system clock. You see here, this is what delayed by 1 cycle of a system clock. Now see up to this. Okay, so this total is how much? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so 9, 10, 11, 12. Okay, so now see here, this is my Q3. Okay, Q3. If I will take the complement, because it is connected to inverter, so I will take complement of this. Okay, complement of this means it is high here and it is low here. I am taking just directly complement. Low here, this is low and this is high. This is high and this is low, and again this high, then this is low. I have taken here complement. This is my Q3 bar. Okay, now what I have to do here? NAND. Okay, NAND operation of these two. What is the NAND operation of these two is nothing but, if you will see here, if you will see here, this 100 is not, its operation is and sorry, this operation is AND. Okay, so this operation is what? And okay, inverter is connected to this input only. Yes, this input only. So output is Q out, Q naught. So then Q naught for this is nothing but Q naught. If you will see here, Q naught is nothing but this 0 and this 1 is 1 and this 1 0 0 remaining 0. Okay, 0 0. So 0 1 again 0 0. So this 1 0 again 0. Okay, so if you will see here, this is 1 1. So 1 1 means 1. This is 0 0. This 0. Okay, so it is what here it is. Now the option is what? It is rising edge. Okay, rising edge of the, see, duration is what? TS. TS duration. TS duration. Okay, so this is nothing but rising edge detector with pulse of Q out with pulse of Q out is equal to 1 cycle of the system clock. It is a rising edge detection. Yes, it is a rising edge detection. Okay, so rising edge detection with pulse of Q out. Okay, rising edge detection. So this functionality, the functionality of this circuit represent what what it what it will represent. It represent the detection of rising edge of the pulse. Okay, rising edge of the pulse of Q out. Okay, with system, with what? With system clock duration of TS. Okay, so therefore here the option B is correct. Okay, so this is about clock this is about this question. Okay, so remember, this is not a flip flop, because for flip flop edge must be there. If it is like edge, then it is behaving like what? It will behave like a what? Flip flop. Okay, D flip flop, but it is a D latch. The difference only is that the flip flop is what? Flip flop and latch. The difference is only that if you see D flip flop, what? D flip flop, it is what? Edge trigger. Okay, edge trigger, either positive edge trigger, either negative edge trigger. Okay, D flip flop. But D latch, if you see here, D latch, this D latch is what? This is a this is level trigger. Okay, so level sensitive. This is just a level sensitive. Okay, it's a level sensitive. Okay, so this is my level sensitive, and this is edge sensitive or edge trigger. Okay, at edge it will get trigger, means output will get changed. Okay, so here output get changed. Okay, or output will change at edge. Okay, either positive edge or negative edge, depending on which type of what clock pulse is connected. Okay, if it is this is positive, this is positive. If it is with inverter, then it is negative. Okay, so depending on this clock, okay, clock pulse, but it is not connected here. This means what? Latch means it will trigger, means output will change only at level. Okay, so it is level sensitive. Okay, output will change during level trigger only. During what? Level. Okay, during this level only output will get change. Okay, otherwise here edge, and during this edge output will not change. Okay, so this is the main difference between D flip flop and latch. Okay, latch is level sensitive and flip flop is edge sensitive. Okay, either positive edge or negative edge. So here it is not given pulse, it is not given here like this. Okay, this is not given, this arrow is not given, means it is just what? D latch. Okay, so this is what? This is the detection of what? Detection of the pulse, the detection of rising edge of the pulse of Q output. Okay, Q output for what? For the system clock duration of a TS. So that's all for this question. So now let us see next question.